going to talk about solving rational equations and radical equations today. So we just have several examples of how to solve them. So a lot of times what we're looking at in rational equations, we're looking at, is there a value that doesn't work? Like if I divide by 0, is there a value here that I can't have? So there's a domain restriction. And then we're going to look at kind of solving those out. We're going to have some concepts on how we want to solve these out. And then we're going to talk about solving radical equations and how to work those out. So in our first one here, we actually have a rational equation here where our denominators are just constant numbers. So if I have a constant in my denominator, what I want to do is I want to multiply by a common multiple to get rid of that denominator. So I know a common multiple of 2 and 3 is 6. So what we're going to do is we're going to multiply everything by 6. Okay? And so this sign ends up not mattering because 0 times 6 is 0. So 3 goes into 6 too. So this top is actually multiplying the top by 2. So this becomes 2x minus 16. And this we're going to multiply by 3. So plus 3x minus 9. And so now I'm going to simplify this. So I have 5x minus 25 equals 0. I'm going to add my 25 over. I have 5x equals 25, or x equals 5. Now, how would I check this? Well, I would check this by plugging it in to see what I get. So I would have 5 minus 8 over 3 plus 5 minus 3 over 2, and I want that, I'm going to check that. So this gives me negative 3 over 3 plus 2 over 2, which is negative 1 plus 1. Is that 0? Yes. So I have checked my answer. Okay? Now, the next one is I have a variable in my denominator. So the first thing I want to do is I want to understand that there is going to be some kind of domain restriction here. Well, what makes the denominator equal 0? What are all the values? So x cannot equal 3. I know that right away before doing any other work is I have this domain restriction. So if this becomes part of my answer set, I know it can't be because it said the domain can't have that. Okay? So now, since my denominators are the same, I can kind of actually ignore them. What I'm going to do is I'm going to solve the expression x squared equals 9. And that's going to give me when these are going to be the same. So now I'm going to square root both sides. So x equals, well, the square root of 9 is plus or minus 3. But what did we say? What was our domain restriction? Our domain restriction said it can't be 3. So it can't be the positive side of it. So x is negative 3. When x is negative 3 is our only answer because of that domain restriction. So our last rational one here is where we have multiple different denominators. Well, when I start this, what I want to do is I want to factor everything. So I'm going to factor everything. So up here I have 2 over, I'm going to factor out a 3 here, 3x plus 2 plus, now I'm going to factor x squared minus 4, which is x plus 2, x minus 2 equals 4 over x minus 2. That's already factored, okay? So now I can actually find my domain restrictions. So my domain restrictions are what makes each of these values 0. So I know x cannot equal plus or minus 2. But here's the unique thing. So when I'm looking at my denominators here, I have to have a common one. So I have to have, my denominator has to have a 3 in it, it has to have an x plus 2, and it has to have x minus 2. So that's my common denominator, is 3x plus 2 times x minus 2. Well, what is this missing? This is missing the x minus 2. So I would have 2 times x minus 2 plus 1 times, well, what is this missing? It is only missing the 3. So I'd have 1 times 3 over 3 times x plus 2, x minus 2 equals 4 times, well, what is this missing? This only has the x minus 2. So it's missing the 3 and the x plus 2. 3x plus 2, x minus 2. So now my denominators are all the same. So now I get to kind of ignore it and only work in my numerator. So I have 2x minus 4 plus 3 equals 4 times 3 is 12. 12 times x is 12x plus 24. Just going to do a little simplifying here. So I'm going to subtract my 2x over, and I'm going to subtract my 24. Okay, so I get negative 25 equals 10x, or x equals negative 25 over 10, which is 5 halves. So there's my value of x, okay? So is this, again, to my domain restrictions? No. So there's my solution. I could plug it back in and test it. To save time, we're going to move on. So I'm going to go ahead and erase this a little bit just to clear up some room here. So now I'm going to deal with radicals. And remember that in radicals, what we're really trying to do is get rid of this radical. So to get rid of a radical, I will square it. Okay, so if I had the square root, I'm going to square it. If I have the cube root, I cube it. The fourth root, I take it to the fourth power, and so on. So here I have my square root isolated, and we want to get the square root to be on one side of the equation and everything else on the other side. What will happen is if we have multiple square roots, what we see at the end is we might have to square this a couple of times, and then we need to be careful because then we start incurring some error and we need to test our solutions. So what we're going to do is we're going to look at squaring both sides here. So that gives me 3x plus 1 equals 16. I'm going to subtract my 1. 3x equals 15. And then x equals 5. Divide by 3. Now, I need to test this. Okay, so I'm going to test this by plugging it back in. 3 times 5 is 15, plus 1 is 16. Square root of 16 is 4. It works out. Okay, I want to make sure I test it so I don't have any extraneous solution. Extraneous solutions are when you're working it out. It looks like it works, like back over here. It looked like we had plus 3, but we know plus 3 didn't work. And so we want to test those back in. So here in our example, the first thing I want to do is I want to isolate my square root. So what I'm going to do is I'm going to move my 5 over to the other side through subtraction. Now I'm going to square both sides. And when I square both sides, remember that it's quantity. It's the whole side squared. It's not just individual parts. Powers are not distributable. So you can't just go, oh, that's x squared minus 5 squared. That doesn't work. Okay, it's quantity x minus 5, quantity squared. So over here I have x plus 7 equals, this gets squared out. I'm just going to quickly FOIL it. X squared minus 10x plus 25. I'm now going to move everything over. So I'm going to subtract x minus 7 minus x minus 7. 0 equals x squared minus 11x plus 18. The nice thing is this is factorable. So this gives me x minus 9, x minus 2. So now x is equal to 9 and 2. I don't want to just stop here. I want to take this, plug it back in to make sure. Okay? So I'm going to take my 9, plug it back in here. I have 9. So I have my 9. I have 5 plus the square root of 9 plus 7 equals 9. So 9 plus 7 is 16. 5 plus the square root of 16 equals 9. 5 plus 4 equals 9. That works out. So 9 works. Now we're going to test 2. Okay? So I'm going to take and I'm going to plug 2 in. 5 plus the square root of 2 plus 7 equals 2. 5 plus 9 equals 2. Square root of 9 is 3. This one does not work. So this is what we call an extraneous solution. So, because remember what it's trying to do here is take the negative side of that square root. So instead of taking the square root and taking the principal side, it's trying to take that negative side. So this one does not work. So our only solution is 9 here. Okay? So now on our last one here, we have square roots on both sides. We have 2 square roots. So the first thing I need to do is move one of the square roots to the other side. It does not matter which one, you just have to move one over. So I have the square root of x minus 3 equals 4 minus the square root of x plus 5. So now I've isolated one of my square roots. And, well, you don't have to move one of these over. You could just square each side, and that's fine. Because what will happen is you'll end up with a square root over here. What happens is you just have to square this twice, because you're going to square it once. You're going to get rid of one square root, but you're still going to have a square root. So then you have to square it again, simplify and square it again. So if I square both sides here, I have x minus 3 equals 16 minus 2 times 4 times the square root of x plus 5 plus x plus 5. Okay? So if I would have just squared both sides, I would have ended up with this, x minus 3 plus 2 square roots of x minus 3 square roots of x plus 5 plus x plus 5 equals 16. Well, I can take all this stuff and move it to the other side, so I just have my square roots done. That's fine. There's lots of ways to get to the same answer, okay? So I'm going to do a little simplifying here. X minus 3 equals 16 minus 8 square roots of x plus 5 plus x plus 5. So this is going to give me 21 here, okay? So I'm going to subtract 21 over. So I'm going to minus x minus 21, minus x minus 21. Well, this was really nice of them. So this gives me negative 24. My x's go away, minus 8, square roots of x plus 5. I'm going to divide by negative 8, and I get 3 equals the square root of x plus 5. Now I have the square root equals some quantity that doesn't have a root. I'm going to square both sides. 9 equals x plus 5, or x equals 4. Test it. So if I plug this back in, I have the square root of 4 minus 3 plus the square root of 4 plus 5. And it's supposed to equal 4, so this is the square root of 1 plus the square root of 9. 1 plus 3 equals 4. That works out. So there's my solution. So there's lots of ways to do this. I could have squared both sides right away. And then when I squared it, I would have had x minus 3 times x plus 5. So remember, on rational ones, you want that denominator to be the same. Look at your domain restrictions. Radicals, you're going to have to do some kind of power manipulation to get it. Okay? There we go.